Before we start, we will give you exactly 30 seconds to try answering this on your own, together with the questions that can be found on the right-hand side of your screen. If you think you need more than 30 seconds, you may pause this video before the start of the discussion. If you think that you don't need the 30 seconds, you may skip this video to the portion of the discussion. Your 30 seconds starts now. Okay, now let's expand this given binomial expression. We have here the binomial expression x minus y raised to the power of 6. To do this, we need to understand the possible number of terms for the possible expansion. With that, we can determine the correct coefficients that will be multiplied for each term, and will also help us to come up with the correct combination of x and y coefficients. If we're going to expand this given binomial expression, we expect a lot of terms, but that number of terms is actually identified pertaining on the exponent of this binomial expression, which is 6. Our n here is 6. This corresponds to the exponent of x minus y. But the number of terms is actually represented here in this question is n plus 1. So if 6 is the exponent of this binomial expression, we expect to have n plus 1, which is 7. 7 terms. We expect to have here 7 independent terms that are combined to come up with the entire expansion. After identifying and answering this first question, let us pause for a while in answering these two questions. We can only answer these two questions once we are done with our expansion. This first answer could help us determine the correct coefficients using the Pascal's triangle. The Pascal's triangle allows us to identify the correct coefficients in this manner. So we have 1, 2, 1. We simply add the coefficients. We still have 1 here. 1 plus 2 is a 3. We have here 3. We also have 1. Another 1 here. 1 plus 3 is 4. We have here 6. We have here 4. And there's another 1. We have here 1. 1 plus 4 is 5. We have here 10. That's another 10. We have here 5 and another 1. The question here is, when do we stop? Okay, we will stop at a portion where we will get 7 coefficients here. Why 7? Because that corresponds to the number of terms. These coefficients here correspond to the coefficients of each term of the expansion. And since we still have 6 coefficients here and there are 7 terms, let's continue forward. We have 1, 6, this is 15, 10 plus 10 is 20, this is 15, that's 6 and another 1. This row here, we have 1, 2, 3, 4, 5, 6, 7 coefficients. This corresponds to the coefficients of your expanded form for this, because then again there are 7 terms here. So what will happen next? Here comes the process. It will be 1, then we will have here plus 6, that's the 6th term. We have plus 15 as our next term. Now notice that even if our operation here is subtraction, we are using here addition. Don't worry, we will also try to include later on the correct signs of the coefficients of x and y. But just for the structuring of this, let's just simply use addition. No need to worry, because once there are subtraction or minus signs later, the minus signs will always prevail. Just for this, let us have 1, 6, 15, 20, 15, 6, and 1 corresponding to this. But these are not yet the final. Okay? That's why we cannot answer this first, succeeding 2 questions. We will answer this once we are done. Now, what do we need to complete here? Pick your next terms, the two terms rather, of your binomial expression. Here, we are going to follow this pattern. The first term will start with its highest exponent, which corresponds to your n, x to the power of 6, okay? And then we're going to move down, meaning we're going to decrease the exponents, so x power 5, x to the power of 4, x cubed, of course, x squared, x to the power of 1 or simply x, and x to the power of 0, which is 1. These are now the coefficients of your first term, x. Okay, don't forget that our numerical coefficient here is just 1. So if we're going to place here 1, 1, we will not have any difference with the result. But if it has another numerical coefficient, you're going to enclose this in your parentheses. We will have other examples for that later. Okay. Now, as for y, we are going to consider y starting here. Okay, so we'll have y to the power of 6 and we'll go down that way. But take note of this, as mentioned earlier, if this is 2x, then we're going to enclose this in parentheses. Since this is not just any y, but this is negative y, we're going to enclose it in parentheses. So negative y raised to the power of 6. Please don't forget that because it will have a different, it will have a very important meaning rather on our result. That would mean if we're going to proceed here, power 5 parentheses as well. If we have y to the power of 4, please enclose it in parentheses together with a negative sign. So we have negative y, we have here cube, negative y squared, okay? We'll have negative y to the power of 1, and you will have here negative y to the power of 0. Now, these are the important coefficients of your first and second terms to be paired with the correct coefficients. In short, our first term of 1, let me write here 1, this would be paired with this. Okay, so we have 1x to the power of 6 times negative y raised to the power of 0, followed with plus 6. We'll have the next pair. We have x to the power of 5, and you have times negative y to the power of 1. Okay, going forward, you will have here plus 15, your next term. Then you will have here x to the power of 4, this pair. Okay, then times negative y, sorry, the square should be outside. Okay, so let us try to move the square outside, and it's very important also to denote that. Then plus 20, you'll have this now, x cubed, okay, this pair, times negative y, you have here cube. Let's continue here because we don't have much space. Plus 15, you will have this pair now, x squared, that's squared, times negative y raised to the power of 4. Then the second to the last pair will be paired with 6x. You have negative y raised to the power of 5. And finally plus, that's 1, times x to the power of 0 and negative y raised to the power of 6. That corresponds to this pair here. Now let's tread lightly and slowly here as we are going to simplify now the terms. This is 1. Any term or expression or coefficient raised to the power of 0 is just 1. So we have here x to the power of 6 plus 6x to the power of 5 times negative y, because negative y power of 1 is just negative y. Take note of this. This will be changed later. Okay. Next, plus 15 x to the power of 4. Notice about negative y, and when it's squared, it will become positive y squared. Hence, again, this negative sign or the parenthesis, which includes the negative sign, is very important. Plus 20 x cubed times negative y cubed. Okay, because negative y raised to 3 is just negative y cubed. Plus, you will have here, I believe we can still write it here, 15 we have x squared and then positive y to the power of 4 as we take the fourth power of negative y. Then let's have a little bit space here, plus 6x times negative y to the power of 5. Then plus, that's 1, this is also 1, y to the negative y power 6 is y to the power of 6. And finally, as mentioned earlier, you don't need to worry about the pluses here because when there are negative signs, the negative sign will always prevail. Negatives, x power of 6, we have positive and negative, so minus 6x power of 5y, alphabetical, right? Plus 15x to the power of 4y squared. This term here, we have positive and negative here, so minus 20x cubed y cubed plus we'll have here 15x squared y to the power of 4 minus, that's positive 6 times negative 1 is minus 6x y to the power of 5 and plus pardon for the spaces y to the power of 6. This is now the expanded form of this expression. Notice the alternating signs, positive, negative, positive, negative, positive, negative, positive. This is made possible because our operation here is negative. At this time, let's try to complete now the answers here. What's the third term? Okay, the third term is this. So the third term is 15x to the power of 4 y squared. Then the last question only concerned with the numerical coefficient of the fourth term, which is this. Earlier, it was positive 20 using the Pascal's triangle, but because of the signs, the numerical coefficient of the fourth term is negative 20. Okay, so please try to review how this is done using this video, considering the signs and the correct operations when dealing with exponentiations. Now, these are the answers to this expansion, and this will not be correct if 1 or 2 or even just one of the terms is incorrect. By the way, how would we know that our answer is correct or not? Look at the degree of each term. We have 6. We have here 5 plus 1, that's 6. 4 plus 2 is 6. 3 plus 3 is 6. 2 plus 4 is 6. We have here 1 plus 5 is also 6 and 6. All of the degree of each term corresponds to the degree of your exponent here earlier. If there's something wrong here, then definitely one of your processes is incorrect earlier. Thank you very much for watching and hoping that you will subscribe for our channel for this video and for more videos related to this. Goodbye everyone.